Hi guys, in today's video I'm gonna show you how to work with logarithms, how you can calculate, or even how can you simplify logarithms or rewrite the expressions as a single logarithms. And this video is dedicated to my students, and especially to one of them, which is called Michaela, who is not attending my classes in these days because she is a very good athlete, and she is now like hardworking, not on math, but on her athlete conditions or properties to become really like good athlete. So let me first start with summarizing a couple of rules for logarithms which will be used for simplifying or just rewriting the logarithms as a single logarithms. First of all, the product rule of logarithms, which basically means the logarithm of a product is the sum of logarithms, and it can be very easily written as log base a of product means multiplication u times v is equal to, and now we will have the sum of logarithms, which basically means logarithm base a of u plus logarithm base a of v. The second rule says how it behaves when we talk about the quotient rule. So log of a quotient is the difference of logarithms, which is quotient means the division, and it means logarithm base a of u over v is equal to logarithm base a of u minus logarithm base a of v. Basically, this is just the question of notation, and in some of English literature you will find as u and v are with the capital letters and so on and so forth, but it simply doesn't matter. Both letters here represents the numbers, so it really doesn't matter how you denote or label the variables in these expressions. And the last rule for logarithms is called power rule, and it says the log of a power, which basically can be written log base a of u to the power of v. Good manner is to provide the parentheses here, is equal to is the product of the power, which in this case is letter v. Okay, the power is letter v, so is the product of the power v times and the logarithm. So the rest remains like this, logarithm base a of u. Okay, so these are our rules for logarithms, which will be used in the next exercises. Let me just put these rules to the right side of the screen so that we have them in let's say in point of view. We can still see them and work with them. In the next couple of minutes, I want to explain and solve a couple of exercises when we will apply these rules for logarithms to solve, like, let's say, tricky logarithms. Because if you would be asked to solve and to find the values of these numerical expressions, it can be really done very easily with applying the rule of logarithms, because if you look at the first numerical expression, you can really, and let me just remind you the definition of the logarithm, which says log base a of u is equal x if, or x, let me just use letter v, is true if and only if a to the power of v is equal to u. Okay, so this is also kind of rule we want to keep in mind when we will be solving such a or finding the values of the expressions, or later on I will show you how to rewrite the expression as a single logarithm. Just let me write here the very basic definition of the logarithm. Log base a of u is equal to v if and only if a to the power of v is equal to u. Again, it doesn't matter if you call this u and this v, the principle remains the same. So let's have a look on the first exercise, which is 3 times logarithm base 3 of 2 take away logarithm base 3 of 4 plus logarithm base 3 of 1 over 2 is equal to. If you want to try it by your own by applying these rules of logarithms, you can do it by your own, and I will now write the result for all the numerical expressions, and you can try it by your own. So the first solution is gonna be 0, the second solution is gonna be 3, the next solution is gonna be again 0, the next solution is gonna be again 3, and the solution of our last task is gonna be 1. So let's have a look how we apply this rule of logarithms for the first exercise. First of all, you apply the power rule for logarithms, which means this expression, numerical expression, can be written like logarithm base 3 of 2 to the power of 3. Okay, take away logarithm base 3 of 4 plus logarithm base 3 of 1 over 2 is equal to. Now, what do we do here? We apply the, for example, let's say this is really a kind of tricky thing. We apply the quotient rule for these two expressions, okay, and it would then lead to logarithm base 3 of 2 to the power of 3 over 4 plus logarithm base 3 of 1 over 2 is equal to. Okay, so we applied here the quotient rule for logarithms, which basically means, and you can read it vice versa, that the difference of logs is equal to logarithm of quotient. Okay, now we do apply the first rule, which is product rule, and it would be then the logarithm base 3 of 2 to the power of 3 over 4 times 1 over 2. I'm sorry. And this would mean that this is a logarithm of 2 to the power of 3 over 4 times 2 is 8, and 8 is really equal to 2 to the power of 3, which then is equal to logarithm, of course, base 3 of 1. And Now you apply the last definition, or the definition of the logarithm, which basically means that you ask yourself 3 to the what power, okay, let me just put it this way, 3 to the what power is equal to 1, and as we already know from solving the exponential equation, we know that 3 to the power of 0 is equal to 1, so logarithm base 3 of 1 is really equal to 0. So we are really fine, and the result is really correct as we were expecting. Yeah. Okay, let's have a look on the second exercise, which is okay, I need to take the results with me as well. So let me do it this way. Let's solve the second task, and it basically means that this can be rewritten like this. And let me explain one tricky thing here. Log 5 to the power of 3 plus log 2 to the power of 5 take away log 4. Now the question is, why could I avoid or not write the basis here? And you should already know the answer, because this is like common factor, and when we use the common factor or not common factor, common logarithm, we don't have to write number 10, as we know that if there is no base written here, we talk about the logarithm base 10 of any number. Okay, so this is really not important. And when you apply again the rules for logarithms, as we have here the sum or the addition, then we apply the product rule, which means it is equal to log 5 to the power of 3 times 2 to the power of 5 take away logarithm of 4, which is equal to, and as here we have the subtraction, it means we apply the quotient rule, so it's gonna be logarithm 5 to the power of 3 times 2 to the power of 5 over 4, and it is equal to logarithm base 10, of course, or common logarithm of, and as you can already probably see, 4 is 2 to the power of 2, and we apply the rules for exponents, so it's gonna be logarithm, so this is gonna be cancelled like this, 5 to the power of 3 times 2 to the power of 3, which is, again, when we apply the rules for exponents, it's gonna be logarithm 10 to the power of 3, okay, and as we again apply this rule or the definition of the logarithm, which says 10 to the which power is equal to 10 to the power of 3. Of course, as we already know from the solution of the exponential equations, the solution or the result of this logarithm is equal to 3. As you can see, we are again right, and we did the solution really properly. Okay. Let me show you one more example, and let's see. And I really ask you to solve these two tasks by your own, as you know, and as I already shown you how to apply the rules. But in these two examples, please be careful, because there is a negative sign in front of the parentheses, so it makes a little bit difference, just a little bit the difference. But if you would apply everything you have learned till now, there shouldn't be a problem. Maybe if I'll have like a lot of time, I will try to show you also the third example, but let's start with the last one. So let's solve this, and let's find if it is really equal to 1. And how can we find that the solution or the number that is represented by this numerical expression is really equal to 1? So we applied again the rules, power rule or quotient rule or product rule. So first of all, we rewrite this one as a logarithm base 4 of okay, as this is the second or square root of 3, it can be written like 3 to the power of 1 over 2, but then if we multiply it by 3, it can be very easily written as, but I'm thinking if it makes sense, but let's try and we will see logarithm base 4 of 3 to the power of 3 over 2, okay? Take away logarithm base 4 3 to the power of 1 over 2 plus logarithm base 4 of 2 to the power of 3. Take away logarithm base 4 of, and now I can see very easily maybe that this can be like 2 times 3, as number 6 is 2 times 3. What can we do now? We will be looking for the same numbers here, like 3 and okay, and apply here. So let me just explain it step by step. First of all, I will apply the quotient rule here. So it would be logarithm base 4 of 3 to the power of 3 over 2, okay, over 3 to the power of 1 over 2 plus logarithm base 4 2 to the power of 3, take away. And now there comes something which is really important to realize. You put the parentheses here and you can write and use the product rule again here for logarithm base 4 of 2 plus logarithm base 4 of 3, okay? This is equal to, you can simplify the expression in these parentheses as you already know the rules for the exponents, and it means you just subtract 3 over 2 minus 1 over 2, so it will become logarithm base 4 of, and this is gonna be 3 to the power of 3 over 2 minus 1 over 2, okay, plus logarithm base 4, you can write 8, no, let's use 2 over 3 minus logarithm base 4 of 2 minus, as the minus is in front of the parentheses, minus logarithm logarithm for base 4 of 3 is equal to, okay. Now as you can see, this is equal to logarithm base 4 of 3 to the power of 2, okay, because 3 over 2 take away 1 over 2 is equal 2 over 2, which basically means it's 3, okay, plus and now let me just rearrange this so that I have these logarithms all together, okay. So it is log base 4 of 3 plus logarithm base 4 of 2 to the power of 3 minus logarithm base 4 of 2 is equal to. Now as you can see, these two logarithms will cancel each other because they have the same value. So if you subtract them, it's gonna be really 0. And here on these logarithms you will apply the quotient rule, and it will become logarithm base 4 of 2 to the power of 3 over 2, okay, which is equal to logarithm base 4 and of 4 is equal to, and now again you ask yourself, 4 to the power of what is equal to 4? And you are correct, your answer is 1. So basically logarithm base 4 over 4 is equal to 1. Maybe you can also realize, and I told you already, that there is also something which says logarithm base a of a is always equal to 1. Okay, so if you have the base and the logarithm of the number like the same numbers, then you can find very easily, or even by remembering this formula, that this is equal to 1. But still, I don't like to remember this one. I prefer to ask myself 4 to the power of what is equal to 4. And of course, the obvious and the only correct answer is that it's gonna be number 1. Okay, so these were the logarithms. These were the logarithms with like, let's say, numerical expressions. And I'm thinking about the solution of one of these two tasks. Okay, let me just show you, and I hope I won't get in troubles when I'll be showing you the solution of this task. Okay, as I need more space here, I will move it down, and let me just show you very quickly how to solve this one. So basically, again, this can be written as a logarithm base a of 6 squared minus, I will get rid of these parentheses, okay, minus logarithm base a of 4, which I will rewrite like 2 to the power of, or 2 squared, minus logarithm base a of 3 squared. Okay, and now again the same thing I was applying before. It means that logarithm base a of 6 to the squared, or to the power of 2, can be written as logarithm base a of, now, 2 squared times 3 squared. Okay, take away logarithm base a of 2 squared minus logarithm base a of 3 squared is equal to. Now this one we use the product rule because we want to have the same numbers for logarithms, and it would say that it would mean that logarithm base a of 2 squared plus logarithms base a 3 squared minus logarithm base a 2 squared minus logarithm a base a of logarithm base a of 3 squared is equal to. And now, as you can see, this logarithm will cancel with this logarithm, and this logarithm will cancel with this logarithm, so the result is really 0. I am pretty sure that you could maybe find the solution the different way, because here this one can be very easily written as logarithm base a of 2 squared times 3 squared over 2 squared times 3 squared, because you applied for this part of the numerical expression, you applied the quotient rule. Okay, or maybe this wasn't the most clever idea to get rid of these parentheses, because you could maybe directly see from here, really from this expression, that you could come to this one. But this is kind of you have to train a lot, let's say a lot, with the logarithms and with these numerical expressions, and train the rules of logarithms to be really like familiar with these shortcuts, or useful shortcuts, to find out that this is then equal to logarithm base a of 1. And now it is equal to what? And again you ask yourself, a to the power of what is equal to 1? And as we already know, the power is 0, because any number to the power of 0 is equal to 1. So basically, and this is again well known, that the result is, sorry, this was a mistake, is equal to 0. Okay, so you try to do the training by your own with these numerical expressions and applying the rule for logarithms. There is one more thing I want to show you in this video, that this one is really useful and not used only for calculating the numerical expressions, but also for solving the tasks. Let me just make some space here. For solving the tasks when we want to rewrite the expression. Okay, we want to rewrite the expression as a single logarithm. Okay, this is something we were training during our today's lesson, and I showed you a couple of examples how to do it, but now I want to give you more like exercises for training. And as you can see, here you have like exercises from 147 to exercise 170. And as you can see, we have a lot of logarithms here, and our goal in this exercise is to rewrite the expression as a single logarithm. As you can see, I have chosen exercises 157 and 158, as I want to show you how to solve these exercises. So let me just make some more space here. Basically, these exercises are very easy to solve, and I think I will show you also another one which can be a little bit hard to solve. But first of all, let's start with exercise 157, which says 5 times logarithm a take away 5 times logarithm b take away 5 times logarithm c is equal to. And if you are really very like quite familiar with these expressions, you can write the solution like by using the method look and see. And you probably know that the result of this exercise is let me just think very quickly about this. The solution is logarithm which is again common logarithm, which means the base is number 10, and it's gonna be logarithm a over b times c to the power of 5. Okay, and the main goal is that you really become professional, and if you see something like this, by doing all of these exercises you can come to this result. But let me explain how to get here. First of all, what I would do to really show you how this can be found very easily would be that I will use the quotient rule, which means that log a to the power of 5 minus, and this is really critical, I would use the parenthesis here, minus, now log b to the power of 5, okay, plus logarithm c to the power of 5 is equal to. What happened here? You just took negative sign in front of the parentheses, and it means you have the addition here, okay? And if you would apply now the product rule for this expression, you will find out that this is equal to log a to the 5th power minus log b times c to the 5th power, okay, and it is equal to. Now you will apply the quotient rule because you have the subtraction here, and it would then mean that this is equal to log a to the power of 5 over b times c to the power of 5, and if you would simplify this a little bit more, it is logarithm base 10, of course, because it's common logarithm, a over b times c to the power of 5. So we have the result. We could really observe and find out if we are trained really well directly from the first line, okay? And the same thing applies on exercise 155. More or less it's the same exercise. So I don't want to show you this one, but instead of this, maybe some of you would ask yourself what and how to solve, for example, this one when there is number 2. Okay, so let me show you exercise 160, which is this expression, and we want to rewrite it as a single logarithm. So basically this is equal to, and now the most tricky question is how to rewrite this one. What do you think? How can we do this? And the answer is very easy. Number 2 is the result of logarithm base 3, because we have logarithm base 3 here, logarithm base 3 here. And the tricky thing, and why am I asking what is logarithm base 3 of which number is equal to 2? So the question is, what is number x here, so that logarithm base 3 of x is equal to 2? And now you're right, the answer is, this is if and only if x is equal to 3 squared, which basically means number 9. Okay, so we can really rewrite this as a logarithm base 3 of 9 minus logarithm base 3 of t squared minus logarithm base 3 of u to the power of 4, and this one is equal to. We can see again that we will apply the same procedure as I did before. So it's gonna be logarithm base 3 of 9 minus logarithm base 3 of t squared minus logarithm base 3 of u to the power of 4 is equal to. It's a good manner to write here also the parentheses, but sometimes you don't need to. It's just the question of seeing the things. So basically this is logarithm base 3 of 9 minus, and I'm sorry I made a mistake, here must be plus of course, minus logarithm, we applied the product rule, logarithm t squared times u to the power of 4, okay? And now as you can see here is the subtraction, so this is gonna be logarithm, sorry I forgot the base, logarithm base 3 9 over t squared times u to the power of 4, and this is our solution of the exercise number 160. Okay, 160, yes, we are right. The result is really like this. Okay, so if you find, for example, number 2 here in exercise 168, you ask yourself, as you can see, all the logarithms bases are 2, okay? You ask yourself, logarithm base 2 of what number is equal to 2? And the answer is, again, coming from the definition of logarithm, 2 to the power of 2, okay, is equal to the power of 2, of course. So you can say that the logarithm base 2 of 4 is equal to. So instead of representing this one as a number 2, you need to represent this one as a logarithm, and then you simply apply again all the rules for logarithms, and you can really rewrite the expression as a single logarithm. Okay, I think this is enough from this topic, and if you really stayed with me till the end of this video, I ask you to solve all the tasks, or maybe you find the tasks which are not like very easy to solve for you, and you try to solve them, and I will provide you with the correct answers, of course. And thanks for watching, and see you during our next video.